Alright guys, welcome back. Again, we have a fairly large topic to go to right now, so sorry for cutting out the intro video, but today we're going to talk about simplifying polynomial expressions. And again, forgive me, you can take a look at all these examples right here if you need a little bit extra help besides my walking through this. But I'm going to just jump right down to some of these problems, okay? Now, important to point out to you guys, polynomial expressions, okay, are when we're talking about having multiple algebraic expressions in one term. So you're going to see a lot of variables, okay, with different exponents. And the important thing to keep in mind is you have to keep similar terms together. So like an x squared stays with an x squared, an x stays with an x, so on and so forth, okay? Now for part A, we are simplifying these down, and you notice there's a minus sign in between your parentheses. So what we can do here is distribute this minus sign in, okay? And when we do this, we get 5 minus 3t plus 7t squared minus 4t squared minus 10t plus 9, okay? Okay, sorry about that. My phone was ringing, and my parents were calling me to see if I was coming over to watch the Steelers game. So hopefully you are watching Steelers game. Just saying. All right, I'm flipping all over the place. Now, after you've done this, we can combine like terms. 7t squared minus 4t squared gives me 3t squared. Negative 3t minus 10t is negative 13t. 5 plus 9 is 14. Done. Okay? That's a simple case there of combined like terms. You distribute the minus sign across. Part B is exactly the same except it's a plus, so I don't even have to distribute, like change the signs around. It just all stays the same. Now part C, this is a FOIL problem. First, outer, inner, last. X times x is x squared. X times negative 1 is negative x. 8 times x is 8x. 8 times negative 1 is negative 8. Now when you FOIL, typically your outside and inside terms that can be combined together. X squared plus 7x minus 8. And we are done. That is a trinomial. It's in standard form, in the highest exponent down to your constant. All is well. Okay? This is the same as a problem like letter E rather. You're just distributing it across. And letter H. Don't get thrown off by the M and the X's over here. I guess the X is fine. But you're just combining like terms then. Part D is like an amped up version of FOILing. Okay, you'll notice I have a trinomial and a binomial, a 3-part and 2-part. So when I do this, the 2-part gets distributed to all three things, both ways. So first the x, negative 2x cubed. X times x is x squared. X times negative 4 is negative 4x. Now when I distribute the negative 5 in, negative 5 times negative 2x squared, I get positive 10x squared. Please note that I put this right beneath the x squared. This is going to help me to organize things. Negative 5 times x is negative 5x. And negative 5 times negative 4 is positive 20. Combine like terms. Negative 2x cubed plus 11x squared minus 9x plus 20. Okay? These problems are not difficult. They require you to be organized. If you are organized, they are not that bad. All right? Let's take a look at two more. Letter F and letter I, then we'll jump to the back page. Letter F, I am simply distributing the negative x squared across. So I get negative 12x to the 5th. You add your exponents. Plus 11x to the 4th minus 3x squared. And we're done. That's it. You're just distributing across. But whenever, you're multiplying exponents, you just simply add them. Or multiply variables with exponents. Finally, letter I can distribute the x into my first set of parentheses, x squared plus 3x, and then distribute the 2 in. 2k plus 2x. Sorry for that's a 2 right there, as bad as that seems. And all I'm doing is combining like terms. I just have 1x squared, 3x and 2x is 5x, and then 2k is just 2k. Okay? Awesome. Alright, on to the back. Now, comes the factoring part. Please hear me out, ladies and gentlemen. On this keystone, you will only factor leading coefficients of 1. However, there will be some times when you have to factor out a GCF. So I'm going to start off with these ones, and I'm going to lead you down into this part, okay? So right here it says, now you try. Here is the best method of doing it. And again, depending on who you have as a teacher, everyone teaches a little bit different. You make a little x. we always do first times last. The first number out here, leading coefficient, is 1. How do I know that? There's no number in front of x squared. 1 times 15 is 15. Put that up top. Next, the 8 goes down low. The middle term goes down low. You are asking yourself what two numbers multiply to give you 15 but add to 8? 5 and 3. Okay? After you have these two numbers, you make two sets of parentheses. You put x and x in both of them, and these two values are what go in here. Plus 5, plus 3. Done. Okay? You can always check yourself with factoring by foiling. X times x is x squared. X times 3 is 3x plus 5x is 8x. And 5 and 3 is 15. Let's take a look at another one. 1 times 20 is 20 up top. Negative 9 down low. What numbers multiply to give you 20 but add to negative 9? Well, 5 and 4 add to 9, but I want negative 9. So we do negative 5 and negative 4. Same thing. Parentheses. Minus 5 minus 4. Done. It's that simple. Please note for number 3, you have to first get it in standard form. X squared plus 3x minus 18. Hopefully you guys can all recognize that standard form just means you go from x squared to x to regular number. Now I do the same thing. Negative 18 goes up top. 3 goes down low. Notice here I'm going to be subtracting to get to 3. What numbers multiply to give you negative 18 but add to 3? Positive 6, negative 3. So x plus 6. X minus 3. Okay? Good, good, good. The best thing to do with this is practice. Okay? Now, I did mention to you, these are the ones up top here that you need to know. These are the ones you have to know. Down low, these look, oh my gosh, really, really hard. But I promise you this. If you see a bunch of numbers and they say factor, you can factor out a GCF. Your GCF number-wise will always be what's out front. It's the only thing they can possibly throw at you. And what I mean by that is you could take an 8 out here. See how all of them have an x as well? Take an 8x out. And I'm left with x squared minus 7x plus 6. And then we do the same thing we did up top with what's inside this parentheses. 6 goes up top, negative 7 down low. What two numbers multiply to give me 6 but add to negative 7? Negative 6 and negative 1. Let the 8x chill out front. X and x. Minus 6 minus 1. Okay? See how hard number 2 is? So very, very difficult. I'm going to factor out that negative 0.6. Leaving me with x squared. If I do, hopefully you guys can see this. I don't know why the glare is so bad. Negative 2.4 divided by negative 0.6. I get 4. Well, that's a nice number. And then 19.2 divided by negative 0.6. Gives me negative 32. Huh, another nice number. Well, you know it. I can do the same thing. Let that negative 0.6 chill out front. Negative 32 up the top. Positive 4 down low. What numbers multiply to give me negative 32 but add to 4? Positive 8, negative 4. So x plus 8, x minus 4. Okay. Finally over here, this is a weirder one because it's not a trinomial, not 3 things, just 2 things. You're looking for a GCF in both of these. What number can go in 25 and 35? Well, 5. And what variable can go in x squared and x? Just x. So I'm left with 5x plus 7. Good. Okay? Alright. Just a few more quick problems for you guys in this part. We're all good. These are called difference of squares problems. Alright? You'll notice that all of them have a minus sign in the middle. This is the only way this works. Watch how simple this is. The same little trick. The last number goes up top, negative 100. Where's my middle term? Hopefully you guys see there is none, so we represent that with 0. What two numbers multiply to give me negative 100 but add to 0? Negative 10 and positive 10. So when I break this up, it's y and y minus 10 plus 10. There you go. Here, I can factor out a 9, because a 9 goes into both of them. So I'm left with x squared minus 4, and I can do the same thing inside of here. Negative 4 and 0, 2 and negative 2. Good. Okay. Over here, what number goes into both of these? Hopefully you guys see it's 2. Take a 2 out. I'm left with 4x squared minus 25. Alright. Here's the little trick. If you run to something like this. You see how all these were perfect squares? 4, the square root of 4 is 2 and 2. Square root of 100 is 10, 10. Ladies and gentlemen, what's the square root of 4? 2. So 2x and 2x. What's the square root of 25? 5 and 5. And we put plus, minus. That's the whole trick behind this. But we can only do it when they're perfect squares and when there's a minus sign in the middle. Okay? Alright. Very last part down here then. You're looking to reduce things down. So for number 1, it says 15x squared over 10x. Alright. 15 over 10 reduces to 3 over 2, because 5 can go into both of them. As far as my x squareds go, x squared over x, let me show you guys a little side note down here. X squared can be rewritten as x times x over x. Can you guys see that I can cancel one of these out, meaning that I have 1x left on top? There you go. Now, as far as your rule for that goes, you take your top exponent, which is 2, and you minus your bottom exponent, which is 1. What's 2 minus 1? 1. You're finished. Alright? Number 2, I'm going to try to go through these relatively quickly, but please feel free to pause the video if I go too fast. 18 over 36 is 1 over 2, and then I have 1x on top. X over 2. Done. Over here, can you guys see how I have an x on top and an x squared down low? I can take 1 away from up top and 1 away from down low, leaving you with x squared plus 6 over x. You might be inclined to try and cancel these out, but in order to cancel out these, I need to have an x over here as well, which I do not have. Therefore, I am finished. This problem is complete. Okay? Look at part 4. X minus 7 over x plus 4. At first glance, you're really thinking to yourself, man, I'd love to cancel those x's out and just get rid of them. However, it's a binomial. In order to cancel something out, it needs to be common throughout all of it. That's your answer. Your answer is just x minus 7 over x plus 4. I can't reduce anything down there. But if you look at number 5, look down low. What number can go into 5 and negative 10? 5. I'm left with 1 minus 2x down low. Now because that 5 is pulled out, I can reduce this. 15 divided by 5 is 3, so I get 3x up top and the 1 minus 2x down low. Finally, this one's a little tricky, so please bear with me. The top part I can factor, it's a difference of squares. So I get x plus 2, x minus 2 up top. If you're not sure how I got this, take a look up here at this problem, because it's exactly the same thing. X squared minus 4 turns into this. Down low, I'm asking myself, negative 2 up top, negative 1 down low. What two numbers multiply to give me negative 2 but after negative 1? Negative 2 and 1. So I got x plus 1, x minus 2. Do you see anything that can cancel out? Yay, the x minus 2's go away. Do-do-do-do-do-do. I get excited too whenever problems work out nice. And then x plus 2 over x plus 1 is all you got, and you are in business. So, I know I went kind of quick to the end part there. If you have to, please pause it, rewind it, rewatch it, or just feel free to ask questions in class. Hopefully this makes a little bit more sense. But as always, keep up the good work and good luck. We are all counting on you.